Hello everybody, this is Mr. Johnson with Algebra 1. Today we're going to be going over some notes on story graphs. So the last unit, or the last target that we did, was creating graphs, drawing them from different examples, like from a paragraph or from a video, or if I told you about a situation and things like that. What we're moving on to next is actually looking at a graph and being able to tell different things about that graph in terms of the context of the problem. So they're connected ideas. The first problem that we're going to start with is actually a graph about smartphones, cell phones. And the graph here has a couple of interesting things. The first is that we have two lines. We have this blue line and we have this yellow line. And you'll notice they're kind of related, as one line is going down, the other line is going up. There are also some interesting numbers here. Not only do you have the numbers that are on the bottom of the graph, but there are numbers associated with the graph as well, like 35% or 36% or 38%. And then also you have 65 and 64 and 62 and so on and so forth. So a lot of things are going on here. So let's go ahead and let's try to pick apart what exactly is happening with this graph. The first thing that we need to notice is that there is a key. Usually on graphs like this, they have a key of some sort to let you know what line represents what variable or what individual. So we have smartphones, which is the yellow, the bottom graph here, and then feature phones, which if you guys don't know what a feature phone is, it's a flip phone or like a slider phone. It's one of those old ones. Now those used to be a lot more popular because smartphones are relatively new, and so that's the relationship it's showing in this graph. You can see smartphones over the years, they've slowly grown in popularity. They just keep going up and up and up. And you see in June of 2012, they are more popular than maybe the feature phones are. Feature phones started off with quite a bit of popularity, 71% it said, and that was back in October 2010. So not that long ago. Their popularity, however, is just decreased and kept decreasing. So if we had to describe the shape of these two graphs, how do they relate? You'll notice the feature phone graph up here, the blue graph, is decreasing. So we can write that. So the feature phone, there we go. Decreasing, and it's not decreasing at a constant rate. It's not straight. It's kind of curvy. It's varying. So it's decreasing at a varying rate. Now, this is opposed to the smartphone graph, the yellow graph right here. It is increasing at a varying rate. Now, one thing that's kind of interesting, since smartphones and feature phones would make up all of the market, if at some point one goes up, the other must go down, because the two percentages here, such as like 56 and 44, or maybe back here 64 and 36, or maybe 51 and 49, all of these percentages have to add up to 100%. Okay, there are no other types of phones out there besides for smartphones or feature phones. So if one goes up, the other must go down. They're related in how they move. Now the next question asks, how does the market share for smartphones compare from October 2010 to June 2012? Okay, so let's go back to the graph. October 2010 is right here. June 2012 is the very last date. So we're asked to the market share for smartphones, right down there. So smartphones, that would be the yellow graph. So when it started, it was at 29% back in October 2010. And then we finished all the way up here at 55%. So the market share, or the amount of smartphones, has increased by quite a bit. So we need to write a sentence that says that. It has increased that is an A, that is an S. Increased from 29% to 55%. And you can figure out how much that is. All you would have to do, so how much of a percent increase, would be to take 55 minus 29. And if you do that, you get 26. So a 26% increase. Sorry, my S's aren't very good. Awesome. So what does it mean when the two graphs cross each other? If you look back up here, one's going down, the other's going up. What does it mean when they cross? You'll notice that they cross and they meet roughly right about here, February 2012. And that means that there are the same amount of smartphones as there are feature phones. They're both equally as popular. This happens in 2012, February of 2012. It's a good number to have in your head. Now, if at any point I'm going a little bit too fast, always feel free to pause the video. Okay, I want you to make sure that you get the information down. That's the most important thing. Not necessarily that you go fast and get the movie done all in one stop. So the fourth question, are the two graphs continuous or discontinuous? And explain your reasoning. So back up here, remember, continuous means that they keep going on. There are no gaps or holes. That would be a discontinuous graph. And if we look at the yellow graph and then we look at the blue graph, there aren't any gaps, there aren't any holes, there aren't any jumps. So these two are continuous. That's a big idea that you're going to have to keep remembering and using. You'll use it later in different math classes, like in pre-calculus and calculus. So there are no gaps, jumps, or holes. Sorry, my handwriting is kind of bad here on the screen. Alright, so does the current trend apply to your class? To answer this question, you actually are going to have to take a poll. So if you take a poll of people who have smartphones and give a number, put that up there. And then if you take a poll of feature phones and put a number, what you need to do is you can compare the number of smartphones to the number of feature phones. Okay? And in 2012, there were just a few more smartphones here than there were feature phones. So in your class, are there just a few more smartphones than feature phones, or are there a lot more smartphones than feature phones? And that's something that you can do to compare what has happened in the past to what is currently happening in your lives. And it's kind of fun. Question number 6 asks, and it says, a latest survey conducted in October 2013 found that smartphones made up 64.7% of the market. Now, does that data fit with the trend seen in the graph above? And we need to explain our reasoning. So 64.7, that is pretty close to being 65%. So 65% would be somewhere up here. Okay, I don't know if you can see it the screen. But if this graph continues, eventually it's going to be up here in the 64-65% range. Now, in terms of time, I think that's fairly reasonable. 2013 would be the next year. So in 1 year, it's possible that it could raise almost 10%. So yes, this seems reasonable. And I would suspect this 65% is probably more close to the percentage and the ratio of smartphones to feature phones in your class. It actually might be a little higher than that. So, going through graphs and answering questions is the big idea of what we're going to be doing. And it's not that hard. You just have to be willing to kind of dig through and ask yourself what certain numbers mean and what patterns are going on in the graph. And then use good vocabulary like decreasing, increasing, varying rates, things like that. Continuous. Those are all good habits to get into. So let's go ahead and let's scroll down or flip over to the next problem. This graph shows the relationship between the number of Mentos being dropped into a 1 liter bottle of Coca-Cola and the resulting height of the soda geyser. Excuse me. So we're going to need to study this graph in order to answer some of these questions. I don't know if you guys have ever seen the videos on YouTube or anything like that, or if you've done this experiment, but if you drop Mentos in this soda, it sprays everywhere. It's like a big explosion. So what these people did is they tested and see like what happens when you drop 1 in, or what happens when you drop 2 in. Okay, and they measured how tall the soda geyser, the soda fountain was. So we need to first label each axis with the appropriate label. Okay, and you'll notice at the very top of the graph, we have Coke height versus number of Mentos. That actually tells us the two variables that we're going to be comparing. Now, Coke height and number of Mentos, we need to figure out which one goes here, okay, on the dependent axis, and then which one goes down here on the independent axis. So if you think for a minute, they are changing the number of Mentos incrementally. Alright, so they're just adding one more every single time. And they are measuring the height. The height is what they are interested in. So that dependent variable is what you are interested in observing. The number of Mentos just kept on increasing. So that's why number of Mentos will go on the bottom. And that's why Coke height goes on the side. Now, one thing you have to think about, okay, what should a good label be for Coke height? Is this going to be in inches? Would we have 0.2 inches or 1 inch, okay, be the geyser height? Would it be miles? Would 1 mile be a reasonable label? If it was 1 mile, that means your liter would blow up and you'd have a big shooting, streaming geyser of soda that would go all the way into outer space almost. So I don't know if that's right. If we look back up here, okay, I don't know if it says in our description. Nope. If we look down in question number 9, it actually gives us the answer. So it is measured in meters. If you think about feet, 1 foot, maybe that would be it, but usually if you've seen the experiment, you know it goes further than 1 foot. So this is going to be in meters, and the letter for meters is M. Now, the independent variable is the number of Mentos, so let's go ahead and let's just write that down. Independent, it's always nice to know this. That is the number of Mentos. That's an S. S's are terrible. The dependent variable is the Coke height, and that's what they're measuring. That's what they're really interested in. How tall is that geyser of soda? And again, it's because you are not changing the number of Mentos in any... misspelled Mentos up there. You're just letting it continue on, okay? So it's just progressing. You're not really changing it or anything like that, even though you're adding more and more Mentos. The thing you're interested in is the dependent variable, and we are interested in the Coke height. Now, is the above graph continuous or discontinuous? We need to explain our reasoning. So if you look at this, all we have is a bunch of dots, not connected. So if we had to go from this dot to this dot, you would have to make a jump. Okay, there's a gap here. If we had to go from this dot to this dot, there's also a gap there. There are gaps between all of these dots, holes, jumps. So since none of them are connected, it's not going to be continuous. This is a discontinuous graph. Now moving on to question number 9. It asks, how many Mentos did it take before the height of the Coca-Cola stream was higher than 1 meter? These are the good questions that we're trying to figure out from these graphs. So higher than 1 meter, and we want to know how long it's going to take for those things. So we need to first find 1 meter. 1 meter is not going to be down here with the number of Mentos. It's going to be over here with the Coke height. You'll notice right there, 1. That stands for 1 meter. So if we draw a line, okay, eventually our general pattern here, going like this, is going to go above the line. It actually happens right there. So we need to figure out how long that took. Okay, this was the first one that it went above, and this is the last one that was right below. So from 4 Mentos we were below, then at 5 Mentos we were above. So at 5 Mentos, the stream or the fountain of soda was larger than 1 meter. Excellent. And how would you describe the shape of the graph? Well, first off, the shape is discontinuous. Okay. And if we had to look at the pattern of the dots, the points, in general, it is kind of making a shape like this. Okay, it is increasing. So that would be a curve that would fit fairly well to this graph. So the shape of the graph, it is an increasing discontinuous graph. And really the pattern here is it was going up really quickly at first. I mean, you can see the gap between the first 4 or 5 points is really steep. But then if you look over here, it's not so much. It's a little bit less steep. So it was fast at first, and then slow. So fast to slower. The largest increase in soda height is also something else that we can answer from the graph. So from where to where? We're looking for the tallest jump. Tallest jump. So if we compare point to point, we went from here to here. That's a pretty good jump. And then for the next one, we went from here to here. I mean, that's an alright jump. Here to here, there to there. So all of these are just getting relatively smaller. Now we were a little bigger on this one, which is nice, but then the rest are pretty shallow. There's not much going on here. So I think between the first and second mento, that's when our highest gap or the highest change in coke height occurred. So from the first to the second mento. Can't spell today. First to the second mento. Alright, let's make a prediction on what might happen to the soda height if 24 mentos were used. So, going back up here, we only got up to 12. Right there. So if we've only gotten to 12, what would happen if we doubled it? Well, at first, when we started adding mentos, it really increased. Okay, that slope is very steep. Now here, it's not quite as steep. And it might be reasonable to think that when we get out towards the end, it's not going to really rise at all. I mean, there's only so much soda that you can fit in one of these bottles. So I'm thinking if we double it and go to 24, the height of the Mentos stream probably won't increase as much. So it probably won't increase as much as it did in the beginning. Now, if you have other opinions, that's okay. It's just a prediction. Okay. That's the nice thing about math, is that you can make a prediction or a guess. Sometimes it's wrong, and sometimes it's spot on. And sometimes other people disagree with what you might think. Doesn't mean that you're wrong, just means you need to test it and see. So, if anybody wants to go ahead and maybe do this experiment, I would be really interested to see the results. You'll have to videotape it and kind of show me what happens. But that's all I have for the notes today. Again, these are the Algebra 1 notes for story graphs, second target. With the rest of your time, you guys can go ahead and work on homework. There should be homework in the back of my big school binder if I haven't passed it out to you. Please make sure that we are doing that. It goes towards the class cup, and it also goes towards your grade, and that you would know and have expertise over the material. So, thank you again, guys, for being attentive, and I will see you guys soon. Have a great night.